Moving into the graphing part of chapter 4. The biggest thing that I can tell you is the foundation you get today will set the stage for graphing everything. The better you know your sine and cosine, everything is based off of that. And so knowing the parent functions that we learned today, over the next couple days we'll add some transformations into that, will be really big for us. So one of the changes, this looks like a normal graph, right? An x and a y-axis, great. But we are graphing trig functions, and so what's going to change is how we label our x-axis. And if you think about the unit circle was created by radians, and so our x-axis gets labeled in radians, which you'll see those like 4 stopping places around your unit circle, pi over 2, pi, 3 pi over 2, 2 pi. That's how we label our x-axis. The y-axis will be normal, 1, 2, 3, whatever. So let's talk about how we label our x-axis. Eventually, you guys will be drawing your own, and there will be a minimum requirement for what you mark on there. We will always draw 4 tick marks on our way out to graph. The 4th tick mark would be like completing one full sine curve, which would be 1 trip around the unit circle. Well, that distance is 2 pi. So this would be marked as 2 pi. What I'm going to ask is that we always mark the 4th tick mark and the 2nd tick mark. And that's going to become more obvious when we start changing the length of our sine curve. So if we go in the negative direction, the 2nd tick mark would be negative pi, or half the distance. A full 4 tick marks would be negative 2 pi. Now, if you want to label all 4, that's fine. You don't need to, but those would be the other stopping points around our unit circle. If we were to take 2 pi and divide by 4, each of those would be a pi over 2, 2 pi over 2, 3 pi over 2. That's all those places we saw around our unit circle. These, the ones that are in green, not required. You do not have to write pi over 2 and 3 pi over 2, but that's what those are, right? Half of a pi, etc. Moving up our y-axis, you do have to mark at least one of those so we know what units you are using in your y-axis. Today we're going to adjust that based on how much our graph stretches and shrinks so that we have an appropriate window to look at. But usually we would go by ones. So 1, 2, 3. And you really only need to mark probably 1 or 2 of those. Once you have one of them marked, they all will go in the same increments. Okay? So that's the labeling part of it, and that's why the x-axis is marked in radians, because our x value is your angle that we're looking at. Okay? So we are going to build our parent function for sine and for cosine. We're going to do sine first. What you see off to the right-hand side here is this little chart, which we have seen a ton of times, right? We always looked at that chart if our angle were to drop us on an axis. And in each of those ordered pairs, and remember it goes alphabetical order, cosine, comma, sine. If we are doing a sine graph, we're looking at the 2nd number in each of those ordered pairs. So if our angle is 0, our sine value is 0. If we look at that as an ordered pair, and I graphed that, that would be the point 0, comma, 0. At pi over 2, our sine value, again, the 2nd number in that is 1. Pi over 2 would be represented by this line. Every line is another pi over 2. So pi over 2 up 1 would be that dot right there. At pi, our sine value is 0, which means we go back to 0 over pi up 0. Down at that angle 3 pi over 2, our sine value is negative 1. On this graph, that would be over, this is 3 pi over 2, down 1. And at 2 pi, we are back to the original, which is a sine value of 0, which would be the ordered pair 2 pi, comma, 0. Now, going in the reverse direction, if I were to look at the angle negative pi over 2, don't bother erasing, okay? Just watch what I have up here. If I did negative pi over 2, that would have been the same thing as 3 pi over 2, right? Sine value of negative 1. So at negative pi over 2, we're down at negative 1. Do you guys see a pattern starting up there? Yeah. Okay, learn that pattern. That pattern will never change for every sine and cosine curve. Once we get that pattern down, you're good. Which means as we go to negative pi, we are back to 0. Negative 3 pi over 2, which would put us up at that 90 degrees, we'd be up at 1. And a negative direction circle puts us again back to the original. 0. So as you can see, we basically go 0, up 1, 0, down 1, 0, up 1, 0, down 1, 0, up 1, and that is not going to change ever. Okay, now we're going to call that 0 eventually our midline, which we'll talk about in a little bit. And the distance we go above and below that midline is going to change a little bit towards the end of today, but it's 1. The standard movement above and below that midline is 1. This down here is non-math words. Okay, we're just going to, in non-math way, tell us where we started. Okay, so when we start a sine curve, I would consider this to be my starting point right here. To draw a sine curve from there, I would put a nice smooth curve between all of those points. The line that I just drew up there in red is considered one sine curve. In a couple days, we're going to learn that its name is a period, one period of sine. What we are looking at is 2 periods of sine. If I were to backfill here, that is actually 2 sine graphs that we see up there, 2 full sine curves. So it starts at, and however you want to describe this for yourself, 0, 0, or if you want to call it 0, or you want to call it the origin, whatever you want to call it, this guy right here is where your sine curve starts, on our midline at 0. Okay. Our first movement then was to go over 1, up 1, or up from there, or off your midline, or again, however non-mathematically you want to describe that from here, we went to this dot next, right? That was our next move. So however you want to non-mathematically describe that for yourself, to kind of remind yourself of the first movement. Because once we get that first move made, then we just follow our pattern. Back to 0 below, back to 0 above, back to 0 below, the whole way across. Your graphs will always be 100% symmetrical. So if we were to like have 0 above and 0 above this way, which would be a common mistake that happens, that would be incorrect. You always have to alternate. Go above 0, below 0, the entire way across your graph. Filling in our cosine curve is going to be incredibly the same, except for as we move our way around the unit circle, cosine is the first number in each of those ordered pairs. So at 0, your first number is 1, which puts the first dot for our cosine curve up at 0, 1. At pi over 2, you have a cosine value of 0. At pi, you have a cosine value of -1. You see that pattern starting again? Okay, it should look very familiar. At 3 pi over 2, we're back to a cosine value of 0. And at 2 pi, a cosine value of 1. These 5 dots that you see right here form the parent function of one cosine curve. And then if I follow that pattern in the negative direction, I would get the second part of that cosine curve. That is a second cosine curve. So in non-math terms, describe to yourself, where did the cosine start and what was the first move you made? So even non-mathematically speaking, I would like say that I started up at 1 and I went to 0. That's kind of like, does that, I mean, maybe that makes sense to you. That makes sense to me. You write whatever makes sense to you. We started up at 0, 1, and we went to the midline first. Well, I know what midline is because I've been through the next slide, but you haven't, but that's eventually what we're going to do. First move is to go to the midline. And that's what you always do. Wherever you start, you're either on the midline, so you're going to move off of it, or you're off the midline, so you move to it. Every other time, your dot is on the midline, which is this line that runs right through the middle of our picture. And I keep saying the word midline, so what is it? Your graph has a line that runs exactly through the half of it, where exactly what's above it is the same as what's below it. So if we were to find the midline of, like, say, this graph, I would find exactly halfway between the highest point and the lowest point. That line is considered your midline. Okay? Now, it's a horizontal line. Horizontal lines are of the format y equals, and it goes through up at 2. So y equals 2 would be the midline of that graph. Using that same kind of idea, look at the graph below that and identify what the midline of that one would be. So where I draw that should split my graph exactly in half, so that what's above matches what's below. You should have picked y equals -1. Any questions? Okay, so when I keep referring to this midline, that's the line I'm talking about. Today, our midline is not going to move. It's going to look just like the two that we have up here. All day today, our midline is going to stay right here at y equals 0. This is how it is created or how it is found, and we'll spend a little bit more time later on talking about adjusting this, but it's created from the maximum value and the minimum value. When they talk about the value of the function, they're talking about y's. What is the biggest y these graphs ever hit? 1. The smallest y these graphs ever hit? That's your minimum value, okay? And our midline is at 0. Well, that will always end up being the average of those two numbers. Your max plus your min divided by 2. I don't particularly love creating a formula for us to have to memorize. You don't have to memorize that at all. You have to understand what it is. It's exactly halfway between the biggest and smallest number, okay? But it's your average. And like I said, today, ours is staying at y equals 0. It will always look like your x-axis today. We will work on moving that in a later day. First semester, we spent a lot of time doing transformations. We learned these parent functions, and then we were like stretching them and shrinking them and shifting them right and left and up and down and flipping them and all that stuff. Well, guys, that stuff's not going away. It just looks a little different when it's in a trig function, and it's actually a lot easier to do. You're going to like this a lot better because we are not going to draw any charts or tables of points. We're not going to have to remember to multiply our x or our y or flip it or whatever. Like, none of that's happening. These are actually a lot easier to graph. But we do need to remember what those transformations are doing. So take us back to first semester. F of x equals 3 times the absolute value of x. What's that 3 doing to our graph? Vertical stretch. It is a vertical stretch, and that's exactly what's happening here. Other reminders, outside things are always vertical. That outside things are exactly what I think they are. So if it's a big number, it stretches my graph. So if I were to switch that 3 to a 1/2, it would be what? Shrink, right? A vertical shrink, because outside things. Now, first semester, we spent a lot of time talking about, okay, which column do I multiply? What are those numbers? We don't need that anymore, okay? It's actually a lot easier to do, which we'll see in just a second, but just a reminder. It's doing the same thing to my graph. It's shrinking it by 1/2. It's stretching it by 3. But it's a trig function instead of one of my parent functions. And because of that, it has a new name, and that's called amplitude. When we stretch or shrink our graph vertically, we are adjusting the amplitude. Okay? And the amplitude is always a positive number because the amplitude is your distance above or below the midline. And we've talked about distance is always positive, right? 10 miles to Gretna, 2 miles to Elkhorn High, even though they're opposite directions, right? Distance is positive. So as we look at this, it's going to look the same as a vertical stretch or shrink, a number multiplying on the outside of my function, but it'll always be positive. So we would say that the amplitude of this first one is 3. Okay, identify the amplitude on the next two. Residual? Don't know. Why did I put that last one up there? Because it's negative, but our amplitude is positive. questions on that? So our standard function will have a distance of 1 above or below our axis. When we start changing the vertical stretch or shrink, the amplitude, that just tells you when I draw a dot that's not on my midline, that's how far away I need to be. Okay? So let's go ahead and jump into doing this. Let's start with our parent function. On all of these, you guys are going to be asked to graph your parent function to start with. So we're just going to graph a perfect sine curve for ourselves. However, I'm going to use this one as an example of talking about adjusting our measurement on our y-axis. Okay? If I look at both of these, this one has an amplitude of 1. This one has an amplitude of 1/4. I could number this like normal, but I could also number it how to make this graph a little bit easier to see when it only has an amplitude of 1/4. By fractions, by like a half and 1, which means a fourth would be like right here. If I numbered this as a half, is that making sense? Okay. I could do that. I don't have to. I could leave it the normal. But I'm going to actually adjust it on this one because I want to talk about you do need to draw this to match the numbering that you have on there. So on this one, my sine curve, remember our midline's not moving today, our midline's going to be here, and my sine curve starts on the midline at 0. That dot will never change. But normally in my parent function, I would go over 1, up 1, but 1 is all the way up here right now, because of how I numbered my y-axis, right? And then I return back to the y-axis, and then I go the other way, down 1, which is actually 2 lines, the way I have it numbered, back to my midline. Fill in the pattern the other direction. So this one was above, which means on this side I need to go below, back to my midline, above, back to my midline, so that every point alternates as I go across the entire graph. Nice, smooth curve. Now, as you start stretching that amplitude more and more, the curves get a little bit harder to draw. Just please make sure you do not draw sharp corners in there. They do not have sharp corners. They should have a nice, smooth curve as we connect all of those. Okay, then our next one is supposed to only have an amplitude of 1/4. The starting dot of sine is on the midline. That will not change based on an amplitude. So they start at the exact same dot. But as I go over 1, up 1, I will only go up as far as the amplitude says. So I'll go over 1, up 1/4, so that this right here matches my amplitude of 1/4. And then we follow our pattern. Return to the midline. Go down the distance of the amplitude, 1/4. Return to the midline. And repeat that pattern all the way back here. Below 1/4, back to my midline. Above 1/4, back to my midline. And you can see, comparing the red graph to the blue graph that I have up there, that the blue graph is only 1/4 as tall as the red graph, which is the difference. Your amplitude is the distance you are from the midline each time, or the number in front of your function, always positive, because it's a distance. Questions? Okay, we have 4 graphs to do. We just did one of them. The second graph on each of these is going to teach us how to do one with a negative. Now, first semester we had a name for the negative sitting outside a function. What was it? ROX. Yes, ROX. Okay, we'll talk about that in a second. Give me your perfect parent function sine curve. It's already numbered for you, so go ahead and just follow the numbering that's on there. We went back to just having our axis numbered in 1. So right, I'm going to go over 1, up 1, back to my midline, over 1, down 1, back to my midline, fill in. given my midline is here at y equals 0. Okay? And then we need to talk about the sine curve. First of all, the second one has an amplitude of 2, which means every time I leave my midline, whether that to be go up or down, I go a distance of 2 instead of a distance of 1. The negative is an ROX, and we haven't talked about that, but an ROX stood for reflection over the x-axis, which is going to take my graph and flip it over the x-axis, which means this point right here that would have been up at 1 instead would be down at -1. It turns that graph upside down. So what does that mean for me as I'm actually graphing it? In a sine curve where we do still start here at 0, 0, our first move for an ROX is to go down first instead of up first. Okay, so instead of going over 1, up 1, we go over 1, down 1, or down actually 2. Over 1, down 2 because of our amplitude of 2. Down because of the ROX. And now we've started our pattern, so now we just fill in. Okay, so I was at my midline, I went down 2, back to my midline, up 2. Back to my midline, fill in the pattern all the way across. Up 2, midline, down 2, midline. Smooth curve to connect those dots. If it asks us to, which I think on your first assignment it will. And again, remember when asked for the amplitude, which is eventually going to be a very common and important question, your amplitude is always positive, right? The negative is referred to as an ROX. The amplitude is 2. Questions? The one that's in, oh, I guess I drew it in green. This one is g of x. So I actually have 2 graphs drawn on this one. The one in red is this equation, sine of x. The one in green has an amplitude of 2, so it got vertically stretched by 2. So it took each of my points in the red graph, and instead of being at 1, it stretched it up to 2. All right, so we're going to do the same thing with our cosine curve. So we're going to start the very first one. Give me your perfect parent cosine curve. So again, our midline is not moving today. Our midline is going to stay at y equals 0 the whole time, which is going to look like your x-axis. Cosine curve starts at 0, 1. So this is the starting point of your normal cosine curve. And then we follow our pattern. Currently, we are off the midline. So my very next dot should go to the midline, right? So we're always going to go over 1. Over 1, next move, to the midline. Over 1, below the midline. Over 1, to the midline. Over 1, above. Remember, that is one cosine curve, and I just repeat the pattern backwards, and that'll fill in this way. Midline, below, midline, above. Eventually, after several days of doing this, we're going to be able to look at this and write it as both a sine and a cosine curve because they are completely related with what's called a phase shift. Like I could start a sine curve here or start a cosine curve here. Does that make sense? So yes, they are completely related, and we'll be able to look at these and write it as both. We're just not quite there yet. Okay, so I will tell you right now that amplitudes and ROXs of cosine curves are probably the most missed thing because of the first point. We still want our first point to be here, but every time I am off of my midline, it has to be this distance. So my amplitude is 2, so instead of starting here, I have to start at a distance of the amplitude. This would be my starting point. 2 above my midline instead of 1 above my midline. And then we go back to our midline, 2 below. Back to my midline, to above. Because every time we leave our midline, it has to be the distance of your amplitude. Back to my midline, to below, back to my midline, to above. Connect all those dots with a nice, smooth curve. I do, yeah. Yep. Yep. Perfect. All right, last one. How do we start a cosine curve that has an ROX? Okay, and like I said on the last one, the amplitude and the ROX starting a cosine curve is probably where we have our biggest hesitation when graphing these, because the starting point on a cosine curve is off the midline. So it does get impacted by an amplitude or an ROX. So draw your parent function for cosine. Our midline does not change. Cosine without a transformation starts at 0, 1. Goes to my midline below, to my midline above. And then the amplitude of 1/2 with an ROX means every time I leave my midline, it'll be a distance of 1/2. But the ROX part of it, remember that means I flip it over my x-axis. So instead of starting above, we would actually, because of an ROX on a cosine curve, get rid of that. You will start below the midline. That's what an ROX means for a cosine curve. Start below the midline, because it took that point that was above and flips it below. And we will only, on this one, go a distance of 1/2. So I'm going to start below because of the ROX, a distance of 1/2. That dot right there, that's where I would start this transformation. We all good with that point right there? And once you get that point, we follow our pattern. We're not on the midline, which means my next point has to be on the midline. So go to my midline, 1/2 above. To my midline, 1/2 below. Fill in backwards, midline, 1/2 above, midline, 1/2 below. Nice, smooth curve. To fill those in, amplitude is always positive because it is a distance above or below my midline. Questions?
So if it's ever on the midline, it will always overlap with the parent function?
Yes. Yes. Okay, guys, did you hear what she said? That's a kind of important thing. When it's on the midline, will it overlap with the parent? Today, none of the points on the midline will ever get impacted by anything we do. So every point that is on the midline should be the same for both of your functions, parent and transformed. Eventually, as we start shifting them right or left, that's not going to be the case, but today it will. The only thing that will change is where it goes off of the midline.
Every first and third.
Yeah. Yeah. Every time we are on the midline, it should be the same. Now, I do want to explain. It did look like you had a book assignment maybe up there, but they were all turned into worksheets, and so they are just like, that's the page it came from. It's the problems out of your book, but put nicely into a worksheet. It's just like the last 4 we just did up there. Please pay attention. Your worksheet is already numbered on the front side. It is not numbered on the back side. You have to number that. Pick it appropriately. For example, this one is a 12 sine of x, which means I would pick something other than 1 because I don't want 12 tick marks running up here for my sine curve, right? So pick your numbering appropriately. Numbering your axis is going to be a very important part of this chapter. Don't forget to do that.